Acceptance angle of optical fiber. Consider a step index optical fiber into which a light is incident at one end at an angle of incidence theta I. A step index fiber is an optical fiber in which the core and cladding regions have homogeneous refractive index. If mu1 is the refractive index of the core region and mu2 is the refractive index of the cladding region, then this mu1 will be greater than mu2. And the refractive index of the fiber changes only at the core cladding boundary. And such a fiber is called a step index fiber. And it is called step index fiber because there is a step discontinuity. Step discontinuity occurs at the step discontinuity of refractive index occurs at the core cladding boundary, and hence it is called a step index fiber. There is a step discontinuity of the refractive index occurs at the core cladding boundary, and hence it is called a step index fiber. So in the case of a step index fiber, the core and cladding have homogeneous refractive index. If this is a core region and it has a refractive index mu1, and this is a cladding region, it has a refractive index mu2, and this is an optical axis. Core and cladding are coaxial regions. This is an optical axis. The inner side is the inner region is the core region, and the outer this is the cladding region. So when a light ray is incident at the core clad boundary at an angle of incidence which is greater than the critical angle, then the ray will be totally reflected into the core region, bottom of the core region, and from this it also reflected totally into the upper region, and hence there is a zigzag movement takes place. So consider such a type of step index fiber. So in the case of step index fiber, the refractive index of the core region is homogeneous and the refractive index of the cladding region is homogeneous. The refractive index changes only at the core cladding interface, and hence it is called a step index fiber. That is, the step discontinuity of refractive index takes place only at the core cladding boundary. Consider such a type of optical fiber, step index fiber, in which a ray is incident into this fiber, and let theta is the angle of incidence of this light ray, and theta r is the angle of refraction. And when the ray enters into the fiber, it goes into this core cladding region. That is, let phi be the angle of incidence at the core cladding region, and this phi will be greater than phi c. This angle of incidence at the core cladding region, it should be greater than phi c, where phi c is the critical angle. Then only the ray will totally reflected into the same medium. So here the angle of incidence, that is this ray, the refracted ray and the normal, it makes an angle phi here. And if this phi is greater than phi c, then this ray will be totally reflected into the same core region. And here also, when this angle of incidence, these lines, it makes an angle with the normal in such a way that the angle of incidence is greater than phi c, then the ray again goes to this direction, that is, the ray will totally reflect into the medium. And if this angle phi is less than phi c, phi is less than phi c, if this angle is less than critical angle, then the ray will go to the cladding region. Then the ray will go to the cladding region. The second, this is the cladding region, these are the, and the ray will go to the cladding region and the signal will be lost. So here the ray is, the incident ray is moving from the air to the fiber medium. It is the air medium, and let mu0 be the refractive index of this air medium. And this is the core region, the green line separated region, it is the core region, and mu1 is the refractive index of the core region, and the outer region is the cladding region, and mu2 is the refractive index of the cladding region. And when the ray enters into this region, into the fiber region, it undergoes refraction, and theta is the angle of incidence, theta r is the angle of refraction and phi is the angle of incidence at the core cladding boundary. And this is the axis of the tube or the optical fiber. And here we are considering the Snell's law in this case. Snell's law, that is a light ray which is moving from air medium to the fiber medium. The refractive index of the air medium is mu0 and the refractive index of the fiber to which the light ray enters, it is the core region, and the refractive index of that region is mu1. So according to Snell's law, when a light ray propagates from one medium to another medium, then the ratio of the refractive index of the second medium to the refractive index of the first medium will be equal to the sine of the angle of incidence, ratio of the sine of the angle of incidence to the sine of angle of refraction. Here the light ray which is propagating from the air medium to the core region to the fiber medium, we are considering the Snell's law. We are applying Snell's law. According to the Snell's law, this is mu0 and this medium is mu1. That is mu1 divided by mu0 is equal to sine of angle of incidence theta I divided by the angle of refraction theta r. This is the Snell's law applied in this region. So if we increase this sine theta I value, then it will changes the angle of refraction theta r. If we increase theta I, it will changes theta r, and also it causes a change in the phi. Angle of incidence ഇവിടെ increase ചെയ്താൽ അതിനനുസരിച്ചിട്ട് angle of refraction മാറുന്നു. അതിനനുസരിച്ചിട്ട് core cladding boundaryയിലുള്ള angle of incidence ചേഞ്ച് ചെയ്യുന്നു. സോ ഈ തീറ്റ ഐ ഇൻക്രീസ് ചെയ്യുന്നു ഒരു പെർട്ടിക്കുലർ ലിമിറ്റിനപ്പുറം. അങ്ങനെയാണെങ്കിൽ ഈ ഫൈയുടെ വാല്യൂ ആംഗിൾ ഓഫ് ഇൻസിഡൻസ് അറ്റ് ദ കോർ ക്ലാഡിംഗ് റീജിയൻ അത് ഫൈ സിയെക്കാളും കുറയും. ഇഫ് ദിസ് ആംഗിൾ ഓഫ് ഇൻസിഡൻസ് അറ്റ് ദ കോർ ക്ലാഡിംഗ് റീജിയൻ ഫൈ വിൽ ബി ലെസ് ദാൻ ഫൈ സി, ഈ ലൈറ്റ് റേ ടോട്ടലി ഇങ്ങോട്ട് റിഫ്ലക്റ്റ് ചെയ്ത് വരില്ല മീഡിയത്തിലേക്ക്, പകരം ഇത് അടുത്ത മീഡിയത്തിലേക്ക് റിഫ്രാക്റ്റ് ചെയ്യുന്നു. ദാറ്റ് ഈസ് ദ റേ വിൽ ഗോസ് ടു ദ ക്ലാഡിംഗ് റീജിയൻ ആൻഡ് ദ റേ വിൽ ബി ലോസ്റ്റ്. അതുകൊണ്ട് തന്നെ the angle of incidence theta should be selected in such a way that this angle, that is the angle of incidence at the core cladding region, should be at least equal to phi c, the critical angle. Then only we can say that theta I will have its maximum value. That is, the largest value of theta I occurs, assume that the largest value of theta I occurs when this angle phi is equal to phi c. So theta ക്ക് അനുസരിച്ചിട്ട് phi ചേഞ്ച് ചെയ്യുന്നു. സോ ഈ theta ഇൻക്രീസ് ചെയ്യുമ്പോൾ അതിനനുസരിച്ചിട്ട് phi ഡിക്രീസ് ചെയ്യും. If the phi decreases below critical angle, then light rayക്ക് ടോട്ടൽ ഇൻറ്റേർണൽ റിഫ്ലക്ഷൻ നടക്കില്ല. അപ്പോൾ ടോട്ടൽ ഇൻറ്റേർണൽ റിഫ്ലക്ഷൻ നടന്നെങ്കിൽ മാത്രമേ കോർ റീജിയനിലേക്ക് അത് വരൂ. ടോട്ടൽ ഇൻറ്റേർണൽ റിഫ്ലക്ഷൻ നടന്നില്ല, ക്ലാഡിങ്ങിലേക്ക് പോകുന്നു, ദ സിഗ്നൽ വിൽ ബി ലോസ്റ്റ്. അപ്പോൾ അങ്ങനെ നടക്കാതെ ഈ ലൈറ്റ് റേ ഈ മീഡിയത്തിലേക്ക് പ്രൊപ്പഗേറ്റ് ചെയ്ത് പോകാൻ വേണ്ടി ആംഗിൾ ഓഫ് ഇൻസിഡൻസ് അറ്റ് ദിസ് റീജിയൻ ഷുഡ് ബി at least equal to the critical angle. We are giving the condition phi is equal to phi c. And we are considering a triangle, that is triangle ABC. From the triangle ABC, this angle is theta r. This is angle C is 90 degree and this angle is phi. In the triangle ABC, angle A is theta r, then angle C is 90 degree, then angle B is phi. And here the theta r plus phi should be equal to 90 degree. Total 180 degree angle. So it should be theta r plus phi is equal to 90 degree. Or theta r is equal to 90 degree minus phi. Or sine of theta r is equal to sine of 90 minus phi. Sine of theta r is equal to sine of 90 minus phi. Then sine 90 minus phi or sine 90 minus phi will be cos phi. So we can substitute the value of sine theta r here as cos phi. then this equation will be, that is, this is noted as equation 1. Then the equation 1 becomes, equation 1 is, that is, mu 1 by mu 0 is equal to sin theta I divided by cos phi. Cos phi. When we are giving this condition, that is, when phi is equal to phi c. When phi is equal to phi c, when phi is equal to phi c, then the theta I, that is the maximum value of theta I, angle of incidence, we are giving it as theta maximum. Theta maximum. Therefore, the equation will be becomes here mu 1 by mu 0 is sin theta I by cos phi. When phi is equal to phi c, this will be sin theta I will be theta maximum. Then this equation can be written as mu 1 by mu 0 is equal to sin theta I is theta maximum, theta max divided by cos phi. Cos phi becomes cos phi c. Phi becomes phi c. This is sin theta max by cos phi c. But we have, let mu 1 is the refractive index of the core and mu 2 is the refractive index of the cladding region. For the total internal reflection to takes place, the mu 1 will be greater than mu 2. And in this case, the ratio mu 2 by mu 1 is equal to, according to Snell's law, mu 2 by mu 1 is equal to, that is, sin phi c. That is, mu 2 when light ray, for total internal reflection, ഒരു light ray ഒരു denser medium നിന്ന് rarer medium സഞ്ചരിക്കണം. Here denser medium is the core region and rarer medium is the cladding region. So rarer medium refractive index mu 2 ആണ്, denser medium mu 1 ആണ്. ഒരു light ray denser medium നിന്ന് rarer medium സഞ്ചരിക്കുമ്പോൾ then അതിൻ്റെ angle of incidence critical angle കൂടുതലാണെങ്കിൽ, അല്ലെ അറ്റ്ലീസ്റ്റ് critical angle ആണെങ്കിൽ, that is when this becomes critical angle, the angle of incidence with critical angle, the ray will graces along the boundary. ഒരു ലൈറ്റ് റേ ഒരു ഡെൻസർ മീഡിയത്തിൽ നിന്ന് റെയറർ മീഡിയത്തിലേക്ക് സഞ്ചരിക്കുമ്പോൾ ഡെൻസർ ടു റെയറർ ബൗണ്ടറിയിൽ വെച്ചിട്ട് അതിന് ആ ലൈറ്റ് റേ ആ ബൗണ്ടറി മീഡിയത്തിലൂടെ ഗ്രേസ് ചെയ്യണമെങ്കിലുള്ള കണ്ടീഷൻ എന്ന് പറഞ്ഞാൽ അതിൻ്റെ ആംഗിൾ ഓഫ് ഇൻസിഡൻസ് ഷുഡ് ബി അറ്റ്ലീസ്റ്റ് 5c, ക്രിട്ടിക്കൽ ആംഗിൾ ആണെങ്കിൽ. Then when the angle of incidence is critical angle, the ray just graces along this boundary. Or the ray makes an angle 90 degree. The ray makes an angle 90 degree with the normal. Or the ray refracts at an angle 90 degree. The angle of refraction will be 90 degree. അപ്പോൾ mu 1 divided by mu 2. Mu 2 by mu 1 is equal to, according to Snell's law, mu 2 by mu 1 is equal to then angle of sine of angle of incidence divided by sine of angle of refraction. Here, when this angle of incidence is phi c, angle of refraction r is 90 degree. So, sin phi c by sin 90 degree, it is 1. So, we can write this equation, that is the condition for critical angle also. The mu 2 by mu 1 is sin phi c, where phi c is the critical angle, the corresponding angle of refraction will be 90 degree. Hence, we can write this equation mu 2 by mu 1 is equal to sin phi c. So, here sin phi c can be written as mu 2 by mu 1, or the cos phi c will be cos phi c. From this equation, cos phi c is equal to root of 1 minus sin square phi c. Sin square phi c. Or what is sin phi c? Root of 1 minus mu 2 square by mu 1 square. Or this can be written as root of mu 1 square minus mu 2 square divided by mu 1. That is cos phi c will be equal to root of mu 1 square minus mu 2 square by mu 1. So substituting this value of cos phi c into this equation. Here mu 1 by mu 0 is sin theta maximum by cos phi c. Instead of cos phi c, we can substitute the values from this equation. That is this one. That is mu 1 by mu 0 is equal to, mu 1 by mu 0 is equal to sin theta maximum divided by root of mu 1 square minus mu 2 square into mu 1. And this mu 1 and mu 1 will cancel. Then Sin theta maximum, we can write it as sin theta maximum is equal to sin theta max is equal to root of mu1 square minus mu2 square divided by mu0, where mu0 is the refractive index of the air medium and it is taken as usually 1. Mu0 is 1. Therefore, the equation is theta maximum is equal to sin inverse root of mu1 square minus mu2 square sin inverse root of mu1 square minus mu2 square, and this theta maxima is called the acceptance angle. Theta maxima is called the acceptance angle of the optical fiber. This theta is called the acceptance angle, that is theta maxima is called the acceptance angle. And the acceptance angle can be defined as the maximum angle that a light ray can have related to the axis of the fiber and propagate down the fiber. So, ഒരു optical fiber ന് attain ചെയ്യാൻ പറ്റുന്ന maximum angle, that is maximum angle of incidence. Light ray ഒരു എയർ മീഡിയത്തിൽ നിന്ന് ഒപ്റ്റിക്കൽ ഫൈബർ മീഡിയത്തിലേക്ക് എൻട്രി ചെയ്യുമ്പോൾ, പ്രൊപ്പഗേറ്റ് ചെയ്യുമ്പോൾ ആ ലൈറ്റ് റേക്ക് അറ്റൈൻ ചെയ്യാൻ പറ്റുന്ന മാക്സിമം ആംഗിളാണ്, ദാറ്റ് ഈസ് തീറ്റ മാക്സിമം. വിത്ത് ദ കണ്ടീഷൻ ഓഫ് ദ ടോട്ടൽ ഇൻറ്റേർണൽ റിഫ്ലക്ഷൻ. ടോട്ടൽ ഇൻറ്റേർണൽ റിഫ്ലക്ഷൻ നടക്കണം വിത്ത് ദ കണ്ടീഷൻ ഓഫ് തീറ്റ വാല്യൂ. സോ ഇറ്റ് ഈസ് കാൾഡ് acceptance ആംഗിൾ. ദെൻ ഈ ആംഗിൾ ഓഫ് ഇൻസിഡൻസ് ഈ തീറ്റ മാക്സിമത്തിനേക്കാളും ഇൻക്രീസ് ചെയ്താൽ, തീറ്റ മാക്സിമം ഇസ് ദ മാക്സിമം വാല്യൂ. ഇഫ് വി ഇൻക്രീസ് ദിസ് ആംഗിൾ ഓഫ് ഇൻസിഡൻസ് above theta maximum, then the ray will be refracted into the cladding region, and the ray will be refracted into the cladding region, and the ray will be, or the optical energy or the optical signal will be lost. So then there will not be any conditions of total internal reflections. So larger the diameter of the core, if you increase the diameter of the core, then larger will be the acceptance angle. Hence, the acceptance angle of an optical fiber is the maximum angle that a light ray can have related to the axis of the fiber and propagate down through the fiber. And here we have considered the angle of incidence theta I and angle of refraction theta r, angle of incidence at the core cladding region phi. Consider the Snell's law. From the Snell's law, mu1 by mu0 is sin theta I by sin theta r. This sin theta r can be changed, that is sin theta r can be converted into terms of phi, that is cos phi. Then this cos phi, when this phi equal to critical angle phi c, the angle of incidence will be maximum, theta maximum. Then the angle of incidence become theta I become theta maximum, and the condition for the total internal reflection, that is mu2 by mu1 is sin phi c. Then phi c can be, cos phi c can be written in terms of refractive index, and finally the value of theta maximum is sin inverse mu1 square minus mu2 square, that is the maximum acceptance angle. This acceptance angle can be expressed in terms of the refractive indices of the core and cladding region.